Today we're going to take a look at the greatest common factor, and then there'll be a separate video for factor by grouping. But the greatest common factor, it's kind of like a weird idea or concept to define, but the greatest common factor is the largest number that goes into multiple numbers. Meaning this, like if I had the number 6 and 8, it's two numbers 6 and 8. The greatest common factor would be a number that multiplies into both numbers. So meaning 6 is 3 times 2, and 8 is 4 times 2. Now 4 is also 2 times 2, and 3 and 2 both primes. We can't do anything with that. But what we should notice here is that they both have a factor of 2, and that's the only factor. So that's the greatest common factor. What if we were looking at a number, and I know I have a couple examples here that I will go through. What if we're comparing 12 and 16? 12 and 16, just start breaking these down. 12 and 16 is 6 times 2. 16 is 4 times 4. 6 is 3 times 2. And then we have that 2 there. So then those are all primes. 16 is 4 times 4 is 2 times 2. 4 is 4, 2 times 2. So then you might notice, well, we have 2. It's like, okay, like I have the factor of 2. 2 goes into 16, 2 goes into 4. But that's not the greatest common factor. They do have the common factor of 2, but the greatest common factor is 2 times 2, which is 2 squared, or 4. So the greatest common factor is 4, because that's the largest number that goes into both 12 and 16. So we're looking for that greatest common factor. So yes, 2 is a common factor, but not the greatest common factor. So that's what we're looking for here. So 36 and 42, and we could do this in the prime factorization. Once you get rolling, though, once you do a lot of these problems, you really start to see, oh, 36 and 42 is going to be this or that. And you don't even have to break it down into prime factorization, but starting off, it might be beneficial, might help. So 36 is 6 times 6, and then 6 times 6 is 3 times 2. 42 is 7 times 6, and then 7 is prime, and then 6 is 3 times 2. And even like right here, I'm gonna pause right here. You could have made the conclusion right here what the GCF is. Like you didn't need to do the breakdown of 3 and 2 because you'd see, well, 6 is just 3 times 2. I have a factor of 6 here. I have a factor of 6 here. So therefore, the GCF is going to be 6 because 7 is prime, 3 and 2 are both prime. I don't have any common factors there. So my GCF between 36 and 42 is 6. That is my GCF. 15 and 25. So 15 is going to be 5 and 3. 25 is 5 and 5. So the GCF is 5. They both have a factor of 5, and that is the largest factor. 44 and 21. 44 is 4 times 11. 21 is 7 times 3. 4 is not prime, but it doesn't really help us to break it down into 2 times 2 because of the fact that 7 and 3 are both prime, and then 11 is prime. So it doesn't really help us out, but I don't have any factors or anything, so we don't have any GCF there. So no GCF on that one. And what you would say is technically 1. The GCF would be 1. Okay, let's move on to variables. X squared, x to the 5th, and x to the 9th. So these are kind of weird at first, like to think about the variables, because x to the 2nd is really x times x, and then x to the 5th is x times x times x times x times x. X to the 9th, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when looking for the GCF, the greatest common factor, how many do they all have in common? They all have 2 factors of x. So x times x. So x squared. So the GCF here would be x squared. Then letter E, you do the same thing. Y to the 6th. If you want to write it out 6 times, write out y. Y to the 7th 7 times. But what you'll notice here is that just, well, this is y. So they all have only a y in common. I don't even need to do anything. Like you're just looking for that term that they just all have. So it's just y, x to the 2nd there, because the other values were greater than that. So they all have at least x squared, or I'll have at least y to the first, and then that's it. Because this term right here, this y to the first, doesn't have 6. This says 6, but it doesn't have 6. So they all have only just 1 in common. Letter F, 8x to the 4th, 12x to the 5th, 16x to the 2nd. So we need to look at each individual term. So let's look at 8. So we want to look at the coefficients, and then we want to look at the variables. So 8 is 4 times 2. 4 times 2 is 2 times 2. Times 2, so 2 to the 3rd, so let's keep that in mind. And then 12 is going to be 4 times 3, which is 2 times 2. And then 16, 4 times 4, and you could keep going, but look, 2 and 2, 2 and 2, that makes 4, 4. Done. Because then I have this prime, I have this prime, and then I have 4, which is 2 times 2, but they don't, neither of the other two have an extra 2 laying around. Like this has a 3, and this one has a 2, but not all of them have a 2. So therefore, the GCF is going to be 4. And then we got to look at the variables. So x to the 4th, x to the 5th, x to the 2nd, and that is going to be x to the 2nd. Because if you, again, look at that visual of x times x, x times x times x times x, and then 5 x's, they all have 2 in common. So x to the 2nd. So 4, x to the 2nd. Letter G, x to the 5th, y to the 5th, x to the 3rd, y to the 6th, x to the 2nd, y to the 10th. We have to look at all of the variables in each pair. This is x to the 5th, so let's go through all of the x's, x to the 5th, x to the 3rd, x to the 2nd. How many do they all have in common? They all have x squared at least, because this one has the x squared. This one doesn't have 5 of them, this one doesn't have 5 of them, but they all have 2. There's 2 in here, 2 in here, but then those have a little bit more, but the greatest common factor would be they all have 2, so x squared. Then we got to look at the y to the 5th, y to the 6th, y to the 10th. So they all have y to the 5th. So our GCF would be x squared, y to the 5th. That's the main concept, is finding the GCF. Now we're going to get into factoring each polynomial. So factoring each polynomial is we're doing the opposite of distributive property. So let's do this down here. If I had like 3 times x minus 2, what we would do is we would distribute. 3 times x is 3x. 3 times 2 is 6. So we have 3x minus 6. Factoring is doing the opposite. It's taking out that factor that we just multiplied by taking out the GCF. So what number goes into both 3 and 6? 3. 3 goes into 3, 3 goes into 6. So I would factor out that 3 to get it back to this spot. So I'm going backwards this time. So let's take a look at letter A, 12x minus 15. I want to take out the GCF, the greatest common factor. And if you look at 12 and 15, you can break it down into prime factorization just like how we did. 12 is 4 times 3, 15 is 5 times 3. But you don't even have to like write that down physically. You just think about factors that go into 12 and 15. Now it might help with something a little bit more complicated, like 72 minus 96 or something like that. You know, like something with big numbers where you got to think a little bit more. But if you could look at 12 and 15 and understand that, well, 3 goes into 12, 15 goes into 15. No, 3 goes into 15. 3 goes into 12, 3 goes into 15. Then my GCF would be 3 because nothing else would work there. So I'm going to take out a 3 from both 12x and 15. And then I can't take out any variables because this is x to the first, but this one doesn't have an x. So I can't take out any variables. They both need some sort of x to take out a variable, but I can't. When I factor out, the operation that I'm performing is division. So I'm dividing each term by that factor, by that term that I'm factoring out. So 12x divided by 3 is 4x. 15 divided by 3 is 5. So I get 3 times 4x minus 5. And if you want to check it, check it. 3 times 4 is 12. 3 times 5 is 15. 12x minus 15. So we should be able to get right back to where we started after factoring out that GCF. And look at your answer, 3 times 4x minus 5. And notice, I don't have any other factors. 4 and 5. 4 is not prime, but 2 times 2. 2 doesn't go into 5. So I don't have any other factors that I could take out. So therefore, I factored it completely. And if I don't catch that GCF, and I only just factor out some sort of factor, then I'd still be left with some factors that could be factored out. But in this case, I'm not. So on letter B, We have x to the 6th plus x to the 8th. So what can we factor out? We can factor out x to the 6th because they both have at least 6. And if you can't visualize that, write down 6 x's, write down 8 x's. How many do they both have? They both have 6 x's. So I'm going to factor out x to the 6th. And when we do that, we're dividing each term by that GCF of x to the 6th. And I don't have any coefficients to factor out because it's just 1x to the 6th, 1x to the 8th. So technically I just have 1x to the 6th. I'm factoring out a 1 if you want to think of it like that, but it's really not. When I'm dividing x to the 6th over x to the 6th, that's the same thing divided by itself. Like if I had 6 over 6, that would just be 1. 6 divided by 6 is 1. Same thing happens here. X to the 6 over x to the 6 is 1. And I'll do a little bit of reminder in a second here on dividing by fractions, or dividing variables with exponents. So let's look at x to the 8th divided by x to the 6th. So x to the 8th divided by x to the 6th. When we are dividing by the same base, we subtract the exponents. So 8 minus 6 is 2, so I'm going to be left with x squared. So 1 plus x squared. And that is factored. Let's keep going. Number 3, we want to factor out the GCF. So let's look at each term. Negative 6, 15, 21. First of all, I have a leading negative, meaning my first term is negative. Whenever there is a leading negative, you want to factor out that leading negative. We always need to take care of that leading negative. So I know for sure when looking at these 3 terms, I have a leading negative, so I'm going to factor out a negative. That's for sure. But now what else could I factor out? I have 6, 15, and 21. Think about this without having to write down all the factors. What number goes into 6, 15, and 21, if any? Well, first of all, 6 is even. 15 and 21 are not even, so we know 2 is not going to work. And then 6 is 3 times 2, so does 3 go into all 3 numbers? 3 goes into 6, 3 goes into 15, 3 goes into 21? Yes. And that's it. Because 6 doesn't go into 15, and 6 doesn't go into 21, so we know we can't do 6, but we could do 3. So I'm going to factor out a negative 3. Now let's look at the variables. X to the 5th, x to the 4th, x to the 2nd. I can factor out x to the 2nd, because they all have 2 x's in common. This one has 4, this one has 5, but they all have at least 2. So I'm going to take out negative 3x to the 2nd. So I'm going to divide each term by that, negative 3x to the 2nd, negative 3x to the 2nd, and negative 3x to the 2nd. Negative 6 divided by negative 3 is positive 2. X to the 5th over x to the 2nd. One more reminder, when I'm dividing by variables, when I'm dividing by the same base, I subtract the exponent, so that's going to be 5 minus 2, which is x to the 3rd. So 2x to the 3rd. 15 divided by negative 3 is negative 5. X to the 4th divided by x to the 2nd is 4 minus 2, which is 2. And then 21 divided by negative 3 is going to be negative 7. And then x to the 2nd over x to the 2nd is going to simplify down to 1, so those cancel out. So that's what we're left with. Leading negative, though, must come out. And then we look for that GCF, and then we factor. Let's look at number 4. 12x squared minus 20x. I don't have a leading negative. I know I have a negative here, but it's not a leading negative, so I'm not going to worry about that. But I do have to look at 12 and 20, thinking 4, right? 4 goes into 12, 4 goes into 20. There's nothing bigger because 12 is 4 times 3, 20 is 4 times 5, so 5 and 3, nothing there. So 4 is what I'm going to take out from that, so 4. And then what else could I take out? Excuse me. X to the 1st and x to the 2nd. I could take out an x because they both have at least an x in common. So I'm dividing both terms by 4x. 12 divided by 4 is 3. X to the second divided by x to the first is x. Minus 20 divided by 4 is 5. And then x over x is just 1. So 3x minus 5. Fractions, number 5. Factoring out a fraction there. Notice the fractions of the denominators, they're all over 3. So 4 over 3, 7 over 3, 5 minus 5 over 3. So we can take out a third. And then I want to look at the variables, x to the second, x to the third, x to the fourth. So I could take out 1/3 x to the second. And what happens here is you don't even have to really think too much, because I'm taking out a third from 4/3. So what am I left with? Just 4. And then that's going to be x to the second, because I'm dividing by x to the second. 4 minus 2 is 2. Minus 7 over 3 divided by a third, it's going to be 7. That's just x. 3 minus 2 is 1. 5 over 3 divided by a third, taking out that third, so you're left with 5. X squared over x squared is 1, so then we get that. And there is our answer. Number 6, factor. We have quite a bit of mess here. We have a leading negative, first of all, so we're definitely going to factor that out. And then we have 50, 15, and 20. So between 50 and 20, we know 10 goes into 50 and 20, but 10 does not go into 15, so we know we can't take out a 10. So then we got to work that down a little bit. That's going to be a 5. I can take out a 5, but I have that leading negative, so I'm going to factor out a negative 5. Let's look at the x's. X to the fourth, x to the third, x to the second. I could take out x to the second, because they all have at least 2. What about the y's? This is y to the third, y to the fourth, y to the fifth, so I can take out y to the third. So let's divide each term by that GCF that I just factored out. So that's going to be dividing by negative 5x to the second, y to the third, dividing by negative 5x to the second, y to the third, and dividing by negative 5x to the second, y to the third. Negative 50 divided by negative 5 is positive 10. X to the fourth over x to the second is 4 minus 2 is 2, so x to the second. Y to the third over y to the third is 1, so let's just completely cancel out. 15 divided by negative 5 is negative 3. X to the third over x to the second, that's going to be 3 minus 2, which is 1, so a single x. And then y to the fourth over y to the third, 4 minus 3 is 1, so that's y to the first. Negative 20 divided by negative 5 is going to be positive 4. Negative 20 divided by negative 5 is positive 4. X to the second over x to the seconds cancel. And then y to the fifth over y to the third is 5 minus 3, which is 2. So y to the second. Notice the answer that we get. It gets a little messy with all these variables, but notice the answer. X to the second, xy, y to the second. Notice that none of them have both an x and a y. Like this has an x, these two have y's, but all 3 of them are missing something. Like this doesn't have an x and this doesn't have a y, so we can't factor out another x or y. That means we captured a GCF, so we're good there. So there is our answer for that one. A little tough. Last 2 for this video. Factor 3 times x plus 2 minus x times x plus 2. What you want to notice here is that we have 3 times x plus 2 and then x times x plus 2. They're both being multiplied by x plus 2. Therefore, our GCF is x plus 2. So we are factoring out an x plus 2. When I do that, look what's happening. I'm dividing by x plus 2 here. I'm dividing by x plus 2 here. X plus 2's cancel. X plus 2's cancel. So what am I left with? I'm left with 3 minus x. And you want to put that x plus 2, when you factor out that x plus 2, you want to put it in parentheses, because if you don't, here's what it's going to look like. It's going to look like this. This looks like you're doing x plus 2 times 3 minus x, but we're not. We're doing x plus 2 times those leftover terms of 3 minus x. So this is not appropriate to write, so I'm going to erase that. You want to make sure you're taking that factor, that x plus 2, and putting it in parentheses, because we want to do parentheses x plus 2 times the 3 minus x, those terms left over. And then number 8, we have the factor of x plus y. And then I don't have anything else here. Don't just look at that factor of x plus y and say that's what I'm factoring out. Just double check everything else. I have a 4x to the 4th, y to the 3rd. I just have a minus 3. 3 doesn't go into 4. I don't have any variables. So I'm going to take out the x plus y. And then I'm dividing everything by the factor of x plus y. X plus y's cancel, both terms. So I'm left with 4x to the 4th, y to the 3rd, minus 3. There's our answer. Okay, so that was just factoring out a GCF.